Hi everybody, welcome back to our Palo Alto studio, theCUBE and NYSE Wired's GTC pregame. The whole industry, the tech industry is descending in Silicon Valley and San Jose, getting ready for the big Super Bowl of the tech industry. And we're going to talk about inference at the edge, building platforms that scale. Everybody talks about training. We're going to talk a little bit more about inference and what's actually happening. We just back from Mobile World Congress, and that's all everybody wanted to talk about. With me to my left is Sid. He's the CEO of D-Matrix. Sid, good to see you again. You've been on a couple of times, and we're going to get the update, as well as Mitesh. You were here a year ago. Mitesh is with Positron. And Sam, thanks for coming in, Sam. He's the founder and general partner at Banyan Ventures. You're doing some cool investments in companies like Felix's firm. He's the CEO of Akash Systems. So thanks, guys, for coming in.
Thanks for having me.
Thank you.
Yeah.
So of course, when we were here last year having this conversation, we've had this conversation at our NYSE studio as well. Yep. Everybody's talking about training. It's where all the activity is, tons of CapEx going in. But sort of the hidden secret here, the gem, is what's going on elsewhere, inference. And you guys are doing some cool stuff all around this table. Give us the update from last time we talked. What's new in the market? What's real? What's hype?
Yeah. So first of all, lots has changed, and it's great to be back with you. Love doing these. It's just a lot of fun. I think we spoke in November.
Yeah.
And oh my God, the world has changed dramatically since November, right? A few things happened. One is, I think the little secret that you talk about, an inference, I don't think is as much of a secret anymore. Right. I think everyone across the world now knows, especially after the NVIDIA-Groq deal that happened in December. There is clear acknowledgement that the next big wave of AI computing is going to be around inference, right? So I think that secret is pretty much out of the bag at this point. And I think people are just trying to figure out what does that really look like, because it's not a one-size-fits-all. This is something we've been saying for a while. You can't really wedge a single computing platform for all of inference, because inference is done at different points in the network. You do it in big data centers, small data centers. We do it in edge applications, right? It's just kind of really spread out, right? And there's big models, small models. There is different metrics of success. How you really, every customer cares about something that's different and unique to them, depending on the applications that they're running. So very difficult to kind of slot one solution into everybody's needs, right? So that's the beauty of the space. I think there's going to be multiple winners. And at this point, I think everyone is deploying compute, not just for training. Training is going to continue, but there's lots of deployments and specific announcements that have been happening literally in the last 3 months around inference capacity and inference deployments. And that to me is very exciting. I think we've all been waiting for this moment. 2025 was that moment when we transitioned away from training only to a training plus inference world, right? And I think 2026 is going to be all about huge announcements around deploying inference at scale, and people trying to build new applications to take advantage of all of that.
So Mitesh, what kind of challenges does that create? Because as Sid was just explaining, there are a lot of different requirements. Is everything a snowflake? How do you deal with that? Of course, he mentioned the Groq deal, Groq with a Q, folks, not the other Groq with a K. So that's great news, right? Because that essentially set the market, tens of billions. So that's good. Confirmation. Yeah. You're not running away because there's so much demand for what you do. But explain your perspective on all this.
Yeah, I think to your point around is everything a snowflake, the kind of answer is yes and no. The point there is that there's many inference applications, and people really care about, different people care about, whether it's time to first token or latency or time to last token or context length. There's so many kind of variables that go into defining an inference workload, right? And I think what happens is people, rightly so, have been using NVIDIA GPUs for training. They're the best in class that is out there for training applications. And then they have been running the inference on NVIDIA GPUs. And NVIDIA GPUs so far have been really the outperforming kind of silicon out there for, especially when you're talking about inference on a dollar basis, right? But what's been proven out, whether it's companies like Cerebras and others, and then companies like Sid's D-Matrix, our Positron AI, what we're coming into the market is like, well, you have many angles to approach this, whether it's fast speeds, that's SRAM-based architectures that have come out, whether it's like high amount of context and memory requirement, because the KV caches are exploding, as people are using applications for code generation, video generation, so this huge amount of memory requirement, right? So all of these different angles means that as much as NVIDIA is at the forefront of technology, there is room and kind of spaces for new companies to come in and really target those applications and really, outshine or really perform on those. And that was kind of the validation around the Groq deal that you mentioned, right? That was the validation of that industry perspective. And on the inference side, what I will say is the other actual challenge is, to your point, and what Sid kind of said, until 2025, training was the majority of spending. We'll see what the numbers in 2026 outline to be, but it's at least going to be kind of even Stevens. And you can just look at one aspect or one stat, right? In Anthropic, literally 15 months ago, was 2 billion ARR. Now it's 20 billion ARR. That ARR is inference ARR, right? That's selling tokens. That's inference. So they have to, even if you assume that they have some level of optimization in that revenue, it's anywhere between 5 to 10 times more compute that they've required within a 15-month period for inference. So whatever they were spending 15 months ago, they have like 5 to 10x that, right? And that's kind of one of the biggest challenges for the industry moving forward is how do we balance, or how do we figure out how to get more and more compute? And this is kind of where people that are different types of computation comes in, because you can optimize on power setup, you can optimize on total throughput, you can optimize on speed of tokens, right? And you can support different applications, and that's kind of the snowflake part of it. But it is going to be very interesting, and it is actually the most exciting time to be in this industry for all of us.
Thank you for that. So Sam, as an investor, I get two questions. Is SaaS dead, and what are you investing in? It was kind of tongue-in-cheek, but I mean, the market just, as Mitesh was saying, it just changed, and Sid was saying it changed overnight. You have to allocate capital in that crazy market. So what's your thesis these days? What are you investing in?
Yeah, so I'm very fortunate. Both companies here, Positron and Akash, I'm a founding seed investor in both of them, and really proud of that. So for me, I focus on AI native infrastructure and AI native vertical application software. And I define that as building with state-of-the-art advantages natively in your product that push what's possible with AI from day one of launching your company. So it feels like some of these changes are overnight, but I think for the infrastructure side, it's been a long time coming. There's a shift happening in the market where we're going from a one-size-fits-all generalization approach of training, fine-tuning, and inferencing with the same hardware to, hey, now you can actually pick the type of inference hardware you would like to pick to get the best watt per dollar efficiency. So for example, with specifically inference in 2024, it was estimated for the compute spend of OpenAI, only 30% of that in 2024 was actually for inference. Now go to 2025, and it's closer to 60 to 80% of their compute spend is now on inference. So we're going from a world of spending a lot of money on training to spending a lot of money on inference, and that power cost, that watt per dollar efficiency of the inference hardware really, really matters, because I think there's a misconception that the hardware costs all the money or the data center costs a lot of money, but if you actually take a step back, it's anywhere between 60 and 70% of the total cost of owning the hardware actually goes to the power cost. Oh, and now we're seeing H100s could last 8 to 10 years. This hardware is lasting a lot longer than people maybe initially thought. And so it's the power cost that is very expensive over the cost of the hardware. And companies like D-Matrix, Positron, and what Akash is doing on the cooling technology really makes the power efficiency much better on a watt per dollar basis. And that's where I'm investing at the inception stage into these companies.
Interesting, when Michael Burry came out with that sort of negative sentiment around the life of accelerators, I actually wrote a piece saying, I think people need to rethink this, because I think the life's going to be a lot longer than folks think. I would say at least 4 to 6 years, and I think that's playing out. In fact, I think everybody was sort of conservative about that. And to the other point, just a finer point on this, so Jensen in his conference calls often says X% of our business is inference. Now, of course, that's inference, as you say, it's the same hardware, basically, whether it was Hoppers or Blackwells,
right.
And a lot of that, of course, was OpenAI on Azure. But you guys are all doing sort of specialized things, and I want to come back to that. But before I do, Felix, you got to explain how you guys fit in with Akash, what you're doing with this really interesting, synthetic diamond, materials. How does it play in helping with this problem?
So I think what we just heard, first of all, thanks for having me. Felix Ejeckam is my name, CEO of Akash Systems. What you just heard from Mitesh and from D-Matrix is a tremendous amount of compute that's coming online and applying tremendous amount of pressure on the grid. There isn't enough power in the grid in the United States to support the kinds of compute that we're talking about here. And if you look at it around the world, it's even greater. I think that the US is deploying 1/10 the amount of power that, say, China is deploying in any given year. So you look at that and say, well, what are we going to do if there's not enough power? We come into the picture and say, well, hold up. You don't need to invest in 100 times more infrastructure to be able to support what the market needs with these new revolutionary technologies that are coming in online. And so what we do at Akash is we've taken a passive invention, piece of lab-grown diamonds, and we use it to cool down very, very hot GPUs.
Can you hold that up? Did you guys
Sure.
get that?
Yeah, okay. This is what a lab-grown diamond looks like, a piece of material that we grow in the lab. And we take this and we apply it. It's a very thermally conductive material. In fact, it's the most thermally conductive on Earth. We put this right on the GPU, and it brings the temperature down by about 10 to 15 degrees Celsius. You don't have to install new infrastructure. You don't have to put any new equipment at play. You take your standard servers, and we've partnered with MyTac. We've got some other partnerships. We actually did this for the first time with a Supermicro server. We also do this with an NVIDIA server, and we apply it together with the server and release it to the market. We just announced release of a 350 intrinsic server with AMD just last week. And that is able to get people like D-Matrix and Mitesh's company online. And by the way, you can bring the PUE to closer to 1.0. He was just talking about, do we have enough power to keep with the dollar per watt curve? Well, PUE is about taking all of the power going into a data center and having most of it, if not all of it, go into compute rather than cooling. You can now do that with diamond cooling.
Okay, and so at what part of the process do you lay that on top of the GPUs? The OEM does that?
So we do it right here in the Bay Area. So we at Akash Systems, we grow this and we put this right on the hot chip, the GPU, and then the rest of the server looks the same, and then we deliver that with our partners to customers. We have this with MyTac Computing. We have another one with the 300 with Supermicro, and we have others that are coming down the pike in the next few months.
I want to follow up on the comments you're making about power. John Furrier just wrote a piece, another preview piece to GTC. He talked about all these constraints. Mm-hmm. He mentioned, fab constraints. Obviously, compute is a constraint. Power is a constraint. We've been working on the premise that our industry has to solve the power problem, or we're going to lose the AI race. So you can brute force it, as you say. The hyperscalers are all building sort of their own, power generation systems. So it seems to be at least going that direction. At the same time, you hear there's still, backlash from citizens saying, "Not in my backyard." Mm-hmm. So you're getting a lot of that. So how much of a constraint? I mean, obviously near term, we know it's a constraint, but we've been going in the assumption that you guys, the industry, is going to solve that. Are we underestimating the industry's ability to solve this problem, or do you align with that premise?
I'll comment on that and say that we actually support not building any new power supply. So you can take your existing power plants, mm-hmm. your existing power capacity, using our technology, and you would get more compute. You can literally turn off the air conditioners in your data centers if you're going to use diamond cooling and not have to get liquid cooling or any of those other technologies, which are fabulous, by the way, but you can turn those off and you get more money back to you as an operator. Roughly, we estimate about $1 million that you get per server operating with diamond cooling in your GPU.
So the economics are very favorable for token generation.
Correct.
The other constraint that John mentioned was, you guys touched on this a little bit, was memory. How have the exorbitant increases in memory affected you? I was out in Utah a couple weeks ago talking to some of the AI cloud companies. 6 months ago, all they wanted was flash, NAND. They didn't want to touch any spinning disk, and today they can't get enough spinning disk because it's significant. You see what's happening to Seagate stock and Western Digital and so forth. How has that affected your business, or is it just Just there's so much demand, it doesn't matter.
So let me touch upon that a little bit. Of course, at D-Matrix, we deliberately built a solution. We knew this is going to be an issue at some point in the future because you have one large GPU-based platform that basically has put a stake in the ground in terms of how that solution is going to be built, and assuming that that solution is the predominant solution, it's very difficult for somebody else to kind of get attention from the ecosystem building something that's going to be similar, right? So everyone here on this panel is trying to do something that's not that, right? And as startups, we have to get creative. We have to hustle. We can't be building that's a me-too product, like the big incumbent in the market, right? So all of us have taken different approaches. In our case, we said we are not going to use CoWoS, which is the silicon interposer technology that packages HBM. We said we are not going to use HBM memory, right? So we have deliberately made a choice where we use SRAM, custom DRAM. I think we've talked about this on the show before, where we stack custom DRAM directly on top of compute. And then we have another tier of memory, which is LPDDR. And we are seeing some spillover effects already into that LPDDR market. The LPDDR market is already beginning to get constrained. Luckily, we use a version of LPDDR, LPDDR5, which is not as constrained as the 4, because 4 is getting end of life very quickly. But we are not as badly affected as anyone who might be using anything that fits into the NVIDIA ecosystem, right? Because that's where there's a real constraint.
Well, to your point, NVIDIA sucked up all the CoWoS demand, and
that's right.
2025
Literally.
it was really problematic. It's easing up a little bit, and I think, but there's still a constraint in the fabs, and now it's shifting to the front end, and TSM has to balance that, and they're not going to build more CoWoS capacity until they can deal with the front end, and so you have to find different ways. Mitesh, would you add anything to that memory discussion?
I think Sid has answered everything. I think the one thing I will just say to it is the prices of memory does affect the entire ecosystem, all the way from HBM to DRAM, including LP5X. Now, to Sid's point, LP5X, much more mobile memory. Actually, the mobile market is not doing that well, so it allows for a better allocation or availability of memory, but the prices have gone up, right? I think just ourselves looking at the prices from literally 12 to 14 months ago to now, and this is not spot market is crazy, right? But even the contractual market, that's gone up a lot, anywhere between 50, 60 to 100 points of price increase in the contracted memory pricing, right? So it does flow through, but I think the biggest point right now is everyone gets affected, first of all, on the memory side, especially the frontier ones, the ones that are using the CoWoS HBM gets even more, and especially to Sid's point, good luck getting allocation for CoWoS and HBM ahead of NVIDIA. Then you have TPU Broadcom ecosystem. Then you have AMD. Then you have Amazon. Then you have Microsoft. Then you have Meta. Good luck, right? So I think it's the point is beyond even the price. Can you get access of important supply chain components that are going to make you make compute, which is the actual true ultimate bottleneck? Because to your point, and kind of just circling back to your original question, your first question around power and how we're going to solve this. Look, from my perspective, I really believe in. I'm a really power maximalist. We have to deploy as much power and build as much power as we can. There's doesn't matter the solutions that Akash does, Positron does, D-Matrix does. Doesn't matter how power efficient we are, how much we save on power. That's all good. That's just adding more to the capacity. But we need still way more power to meet all the demand curves. So obviously rose-tinted glasses here, living in the bubble, whichever way you want to term it. But the point there is just that we need a lot more power if the demand curve is even remotely going to keep on going the direction that it's currently trending towards, right? And so that's that.
I mean, Sam, there's no indication that the demand is waning. In fact, of course, data center accelerators are sucking up all the demand because they're making commitments so much larger than, say, the typical consumer, than Apple and the others are not growing as much. So you really have to get into the value chain and figure out where you place your bets. So how do you think about that and in terms of where do you want to be in that value chain? Do you want to be in, throughout to hedge your bets? Do you want to sort of double down on any particular, zone in that value chain?
Yeah, I mean, for me, I think I spend a lot of time. There's two different types of companies. So Felix and his company is a material science company that's servicing inference, servicing training. And I think that in that type of market opportunity, there has to be a paradigm shift. So for Felix, you know, diamond's the most thermally conductive material in the world. You're saying, hey, it's cools the server better than air conditioning. It cools the server better than water could. That's a paradigm shift. No one's like quite done that yet at scale, so that's a place I would want to be. Or with Positron focusing on ultra specializations for transformers. You know, they're now working with Oracle. That was became public, not to steal your thunder,
No,
but
you're
like,
good.
it's public knowledge now. The Oracle CEO mentioned Positron. And so finding specialization, finding where the ball's heading. And if you like zoom out and look at the Banyan portfolio, there's strategic bets across this entire new highly specialized infrastructure stack. So we have Falcom. I can't say who led their round, but one of the largest space companies in the world. They're the most specialized chip for 5 and 6G communication. Or the biological computing company, they just announced their large seed round. They're using human synthetic brain neurons to replace silicon chip development. I was a pre-seed investor. And you could just go down the list of the companies I've backed very early on, and they all have a fundamental new way of solving a very big problem. And then if they get that right, it can be a real business, have great margins, and add a lot of value to, you know, the markets they're solving. So I'm looking for those very early on, because those problems have to get solved. We can't just keep doing things the way we're doing them, because there's a lot of plateaus in innovation. And I think that's something I see quite a bit, is especially in infrastructure. Like, for example, if you go to any of the 5G towers around us right now sending signals to our phone, most likely that technology is like 20 or 30 years old. So who's going to be the startup daring to change that, and who's going to back them very early on? That's what I do at Banyan.
Well, Mitesh mentioned the B word, bubble. Congratulations on the Oracle deal, but you see Blue Owl and Oracle and of course OpenAI's commitment, but from an investor standpoint, you want to be in the wave. If it's worse to not be in than to be in, and then at some point, you know, maybe there's going to be some overcapacity, we'll deal with it, but you can't not be in it now. I wanted to come back to you, Felix, and ask you a question, because something Sam said caught my attention. I mean, you're not essentially obviating the need for liquid cooling, are you? Or are
No,
you?
we're not.
Yeah,
No, we're not.
Complementing that, right?
Correct.
Because the curves that we're on are going to require, you know, these types of technologies.
We complement both air and liquid. Now, if you don't have the money to invest in liquid infrastructure, then we can support you and help you get to a 1.1 PUE. But if you do have the installed base infrastructure for liquid, then that's fine. We'll help you get some money back in ROI. TCO will look very good.
Yeah, if you can get to a 1.1 PUE, I mean, that's good news. I mean, a lot of the enterprises that I talk to are saying, well, you know, we have to rethink the data center infrastructure, and they're not really set up for liquid cooling, so this could be a bridge for that, for sure. And then, Sam, you mentioned cell towers. So again, I started at MWC last week, and you know, John Furrier wrote this piece a while ago talking about the hyperconverged edge. You basically compute, storage, networking, Wi-Fi, fiber, basically a mini AI factory, you know, within these cell towers. And it's interesting because as you know, the telcos have missed every monetization opportunity since, you know, for quite some time. They're great at connectivity, and of course they wanted to monetize 5G, and they kind of really didn't. Are you seeing, you know, these types of applications emerge? The one that we saw was they'll help you optimize your phone bill. It's like, okay, what else do you have that AI can help me do? You know, like real applications. I mean, they weren't great at content, but who's going to win that game? I mean, obviously the over-the-top vendors won sort of the last round. Are you seeing applications emerge, you know, at the edge that are interesting, or are you guys just so head down trying to be the enablers and let the rest of the value chain figure it out?
Yeah, I mean, it has to start somewhere. It always starts in the core, right? I mean, so you put intelligence into the core, applications get developed into the core, and then, you know, it diffuses from there into many other places, right? That is exactly how it's playing out, right? I mean, you saw a lot of intelligence being deployed in the core. I think there's going to be a lot of intelligence still deployed in data centers and in the core. But I think for the first time, people are now realizing, wow, you know, there's an ability to take these models, distill them down, and deploy it in smaller form factor computing applications that are closer to the edge. And, you know, what would that look like if all this? Eventually, the vision is intelligence will really diffuse to pretty much anything that it can diffuse into, right? And it starts in the core, but, you know, why stop at anything? Every object that you see around you could have some form of intelligence built into it, depending on the environment that it sits in, and can make decisions based on that, right? So in our opinion, this is going to diffuse everywhere. As a company, we are focused in the core because that's where the revenues are, that's where the market opportunities in the near term. But the way we have built our platform, at least, it's built with chiplets, and it can, over time, we can sprinkle these chiplets in a rack, right, and kind of, deploy it in a core application, or over time, kind of strip it down and just distribute, sprinkle fewer chiplets in an edge application, right? And so we deliberately built it with that vision that, look, start in the core, let it go diffuse in the edge, and the platform should be built in a way whereby it can be deployed anywhere, right?
I want to ask you guys, we have to wrap, but it's so hard to predict, right? Things change so fast. But reasoning kind of saved the business in a big way. Yep. Right? If it were not for reasoning, who knows, maybe the bubble would have popped earlier. We don't know, but what is the near-term sort of milestone that you guys are hoping for, optimizing for, expecting? You can't look out 3-5 years. I mean, it's just, you can, but actually maybe it's safer to look out 5 years than it is 18 months. But are there any particular milestones that you're hoping coming out of GTC that you're, obviously Jensen's going to talk about the Groq deal. You're going to, I'm sure you guys are going to be paying attention to that. Is there one thing that you guys are looking for, expecting, hoping for in the next 12 months? I'll start with you, Sid, and go around.
I think, going back to one of your earlier comments, right, is, revenue is being held back because there's not enough energy available, right? So it's what, $10 billion for a gigawatt of capacity, right? That's the number, right? And OpenAI has been pretty public about that, right? Like, hey, look, we just don't have enough. I wish I had more capacity and I could unlock more revenue, right? And so I think clearly the path that we are on is not going to get us there, in the sense like just brute forcing it, throwing more GPUs, right? So I think this whole heterogeneous computing movement, whereby people actually for the first time are embracing alternate architectures. And I'd like to see some numbers in a year from now that clearly show that by taking that approach, we were able to unlock more revenues for applications that people care about, right? We haven't seen that yet. Yeah. So that's something I'd like to see.
Thank you. Mitesh?
Yeah, for me, the excitement is always on the model development side. I think, to your point, reasoning was very important because obviously exploded the amount of tokens, but also it really allowed for problem solving to happen very, very well. Right now, continual learning is supposed to be one of the key things where the model, while it trains, learns, while it's doing inference, learns too. So those are the two spectrums, right? I think in the middle, I think what we will see in real time is we are seeing context length increase without degradation. I think that's the key for next kind of next level of good problem solving. Especially around scientific applications, around world building. It's like, okay, how do you go from 200K to million to 10 million context length, but without the degradation that currently happens? Even Anthropic and OpenAI that are saying 1 million context length, the degradation is because you have to set up attention over that. So that's kind of really one of the key aspects to me. And I think the second aspect is really around this whole, whether you call it world models or alternative transformers, whichever way we look at it, I think the world simulation models will be very interesting, of not only just having a true physics engine at its core, but then, hey, do they open up new challenges for ecosystems for silicon, right? Like, do they work great on Positron or D-Matrix or NVIDIA, or you need something else for those? And that will be another interesting kind of point to the industry. It's like, oh, like this is another type of architecture that we need, right? And I think obviously we are constantly looking ahead, and we try to fit our narrative in there too. But I think as those applications scale up, when you're truly, when rightly so, NVIDIA and Jensen says that they're going to design these factories, in simulation, or when he says every pixel will be generated and not rendered or shot. I think those days when they arrive, that's the level of compute that will require is unfathomable today, right? And I think how do we address that? I think, and that will be really clear in the next 12 to 15 months, especially around the model growth side of it. So it's super exciting for all of us to actually be a part of it. And this is the key validation. To your point, you mentioned about the NVIDIA-Groq deal, but not just that. I think over the last 6 months, as I said, inference is not a secret anymore, and we have to accept and be humble that, like, look, NVIDIA is well over 90% of the world's compute supply, and they're going to own most of the supply chain principles for many coming years, right? I think the thing, though, is that the market is so large that we have to just make sure that our technologies are unique enough and performant enough, and that we can source our supply chain for enough of our allocation. When people call me and say, hey, can you get enough memory? Yeah, if I was NVIDIA, I can't get enough memory at that scale, but I'm Positron, and I'm finding my way through. Yeah, I can get enough memory for our chips, right? So I think that's kind of the key point.
And Sam, you have to have patience. I mean, it takes 7 to 10 years just to get to a company to a point where it can even achieve escape velocity, and that in and of itself is just a real grind. But what are you looking forward to, hoping for in the next 12 months?
Yeah, so for me, when I take a step back, if we just think about ourselves, we can only learn so much in a day, we can only remember so much, we can only communicate so much. I can only communicate in one language, but if you look at AI can speak multiple languages. AI can work 24/7, ingesting information and then reciting it back to you in a very eloquent way. So I'm really excited about this shift in humanity where, for the first time, AI is generating more intelligence than humans. And I think if we look throughout history, we've always assembled ourselves around infrastructure, whether it was trains or electricity or airlines and flying. So I think AI and the intelligence it creates is becoming the new norm in our society. It's a generational shift. And so all these amazing founders that I'm able to work with, just backing them and helping them build out the expertise in their specific areas, I think gets us just a little bit closer each day to that promise of abundant intelligence. And then that unlocks a bunch of great stuff for society, whether it's in medicine or transportation or helping our environment. All these really great societal impacts come from that abundance of intelligence.
Thank you for that. And then Felix, it seems like your expertise in material science, your firms, really have stumbled upon probably the single biggest constraint in the business today, and the economics, from what you said, are pretty much durable. But what's your hope for the next 12 months?
So 12 months out, my hope is more of, not to be negative, but I'm concerned about some of the existential threats to the revolutions that we all speak of. I think that the war currently going on in the world is potentially problematic. The revolutions that we are all talking about, I think the ball has been set in motion. They're going to happen in the next 12, 24, 36 months. Various verticals are going to see so much tremendous leap in the way that we as humans conduct our lives. Medicine, I think, is going to see tremendous revolutions, but all of that could get tripped if we don't fix this war going on, if it doesn't come to an end. And so that's my biggest concern. There's a tremendous amount of our supply chain collectively depends on the Straits of Hormuz, and that could be affected. We just talked about the price of memory. What if there is no memory to buy for 6 months? What does that do to all of our manufacturing? So those are the things that concern me about the next 12 months. But I think in the long run, probably things will sort themselves out, and much of the transformations that we speak of will come to be.
Yeah, thank you. We hope and pray for a quick exit to this this war that's going on right now. In the Middle East looked like it had so much potential and was putting in capital, and so we don't need this. So, all right, guys, thanks so much.
Thank you.
Really appreciate your time.
Thanks, Dave.
All right, and thank you for watching theCUBE and the NYSE Wired GTC pregame. I'm Dave Vellante for John Furrier and the entire CUBE team. We're right back right after this short break.